Assalamu alaikum class. My name is Hammad Hafeez and I am going to discuss unit number 3 with the help of this presentation. And so let's start. Basically, in unit 3 we primarily discuss about symbols and writing a chemical formula which consists of both simple formula and ionic formula. So as far as symbol is concerned, it's very simple that in the case of symbol, basically every element consists of a symbol. Like sodium has symbol Na. Why sodium is have symbol Na? Because its native name is natrium. So due to this name, sodium has symbol Na. Similarly, potassium has symbol K. Calcium has symbol Ca. Magnesium has symbol Mg. So these are the symbols. We write the symbols of element for our A's, and we use these symbols in chemical formulas. Whenever we write chemical formula, we use these symbols for our A's. So let's start. Formula are basically the combination of symbols that represent a compound. A formula basically indicates which element are involved and the number of atoms of each element contained in the compound. Every formula has particular number of atoms, specific number of atoms. For example, if we write about carbon monoxide, so it has symbol like CO. Carbon stand for C stand for carbon, and monoxide means mono mean one oxygen, so CO. If we are supposed to write the formula of carbon dioxide, we write CO2, and this 2 is in lower case, in subscript, lower down. So in the right lower corner, we write this subscript, and carbon dioxide, CO2 for carbon dioxide. So similarly, there are particular atoms like if sulfur trioxide, it has symbol SO3. Tri mean 3 oxygen. Similarly, if we have formula dinitrogen tetraoxide, we write dinitrogen mean 2 nitrogen, N2, tetra mean 4, N2O4. N2O4 is the formula of dinitrogen tetraoxide. We use particular atoms, like dinitrogen means 2 nitrogen, tetra mean 4 oxygens, so N2O4 is the formula for dinitrogen tetraoxide. In writing formula, we use subscript and parentheses in addition to the symbols of element. Subscript mean H2. We use this 2 here. I already mentioned this example, like if carbon dioxide, in the case of carbon dioxide, the 2 should be right in subscript, so indicates the number of atoms in an element as H2, where 2 subscript means two hydrogen atoms. If there is no subscript with this symbol, it is assumed that there is only one atom. For example, in the case of oxygen, in the case of carbon monoxide, we simply write CO. So that means there is one oxygen. There is no need to write one. Parentheses or brackets are used to separate the radicals, polyatomic ion, from the rest of the formula when it would be confusing. This will you will familiar with this concept in later on in this video, what is meant by parentheses, why we separate them. Inshallah, I will explain in later on. Next, steps in formula writing. First of all, determine the symbol for the element in a compound. If we have compound like calcium chloride, if you are supposed to write the formula of calcium chloride, the first prime step is to determine the symbol. There must be calcium and chloride. You have to know about the symbols. So the first step, determine the symbol for the elements in the compound. Next, for example, potassium has symbol K, sodium has symbol Na, calcium has symbol Ca, magnesium has symbol Mg, aluminium has symbol Al, silver has symbol Ag. And determine the valency of each atoms. The second step is to determine the valency. How can you identify the valency? It's very simple. To determine the valency. All the first group elements like lithium, sodium, potassium, rubidium, cesium and francium, they all belongs to first group. Their valency should be 1. Why their valency is 1? Because their outermost electrons are 1. They have 1 electron in outermost shell. For example, in the case of lithium, it has 3 electrons. Its electronic configuration should be 2-1. Sodium has 11 electrons. Its electronic configuration should be 2-8-1. Potassium has 19 electrons. Its electronic configuration should be 2-8-8-1. So you see that there is only 1 electron in outermost shell. So if there is 1 electron in outermost shell, in the case of metals, it has valency 1. Second thing is the group number 2. Group number 2 elements are like beryllium, magnesium, calcium, strontium, barium, radium. No need to memorize these elements, or because you are supposed to see all these elements from periodic table, and you are given periodic table in your exams. Beryllium has proton number 4, magnesium has 12, calcium has 20. So if you write the electronic configuration, it becomes 2-2, it becomes 2-8-2, and in the case of calcium it is 2-8-8-2. So they have 2 electrons in outermost shell. So whenever they lose 2 electrons, they get 2 plus charge. So all these second group element, their valency, it should be 2. Similarly, the group 3 elements, in the case of boron, aluminium, this group, boron has 5 electron in outermost 5 total electrons. In the case of aluminium, it has 13 electrons. In order to write the formula, the electronic configuration, it becomes 2-3 and it becomes 2-8-3. So you see that there are 3 electrons in outermost shell in the case of third group elements. So its valency is 3. Similarly, whenever when we talk about Group number 4, they have 4 electrons in outer shell. For example, carbon, its electronic configuration is 2 4. So the group 4 elements valency should be 4. Now in the case of fifth group, its valency should not be 5, because in the fifth group, for example, in the case of nitrogen, they have 5 electron outermost shell. Its total electrons are 7. So they need 3 electrons in order to complete its octet. So fifth group element has valency 3 rather than 5. They do not have 5. Some elements have 5 valency. They may form 5 bonds, but it's exceptional case. In generally, the fifth group elements, their valency should be 3. In the case of sixth group element like oxygen, it has 8 total electrons, so its valency should be 2, because it needs 2 electrons to complete its octet. So sixth group elements, they have valency 2. Similarly, seventh group elements, they have total 9 electrons. Its electronic configuration should be 2 7. So its valency should be 1, because they need only 1 electron. So you see that valency first increase until 4 and then decrease 1 2 3 4 and then 3 2 and 1. It's for first group, second group, third group, fourth group, fifth group, sixth group elements, and then seventh group elements. They have the respective valencies. So you easily see from periodic table the valencies. Now determine the valency, and then like potassium has valency 1 plus, sodium has valency 1 plus, calcium has valency 2 plus, magnesium has valency 3 plus, silver has valency 1 plus. Write the positive element symbol first, followed by the negative elements. Always write positive elements first and then negative elements. Positive elements means metals. We choose the example of calcium chloride. We choose the example. We are supposed to write the formula of calcium chloride. In the case of calcium, you determine the valency of calcium. Its valency is 2 plus. You first write calcium and then chloride, and chloride belongs to group number 7, so its valency should be 1 minus. So this is how you determine the valency and write positive ion first and then negative ion. All the non-metals, they are negative, all the metals, they are positive. So you write metal first and then non-metal. Names and symbols of the some ions are present here. You can easily check the names. Now rules for writing the chemical formula. The valency or charges on the ions must balance. I'm just explain this concept. Now calcium is 2 plus charge and chloride is 1 minus, so its valency is not balanced. So there should be 2 chloride in order to balance calcium, because calcium has double positive charge but chloride has single negative charge. So in order to balance the number of positive, keep in mind that the positive charge should be equal to negative charge in a chemical formula, because the compounds are stable. Stable means their positive and negative charges are equal, just like atom. In the case of atom, you see that number of electrons should be equal to number of protons. So this is how atom is stable. Similarly, in a compound, number of positive charge should be equal to number of negative charge. So in order to write the formula, there are several rules. one of the rule is to cross the charges. Like calcium has 2 plus, chloride has 1 minus. You simply cross the charges. These two you write here in the subscript of chloride. The charge of calcium become the subscript of chloride, and there is no need to write 1. So the formula of calcium chloride should be CaCl2. And you see that total chlorides are 2, so they have 2 minus. One chloride contain 1 minus charge, so 2 chloride mean 2 minus charge, and it is equal to calcium charge because calcium belongs to group number 2. It should be 2 plus charge, so the positive charge and negative charge is equal. So this is the correct formula of calcium chloride. Let's take another example. For example, if you are supposed to write the formula of magnesium nitrite. So magnesium belongs to group number 2. It must contain 2 plus charge. Nitrite means nitrogen belongs to group number 5. It must contain 3 minus charge. So in order to write the formula of magnesium nitrite, you crisscross the charges. It become Mg3 and N2. This is the formula of magnesium nitrite, Mg3 N2. In order to prove this, either this formula is right or wrong, you simply see that number of one magnesium ion contain 2 plus charge, so there are total 3 magnesium. So overall positive charge is plus 2 multiplied by 3 is equal to 6 plus 6. Overall the charge of 3 magnesium is equal to plus 6. Now 1 nitrogen contain 3 minus charge. Whenever you multiply the number of nitrogen atom, it contain minus 6. So it is equals to plus 6 is equal to minus 6. So that's mean this formula is exactly right. So this is how you write the formula. So let's take another example. You are supposed to write the formula of calcium oxide. Now calcium oxide, in the case of calcium, it belongs to second group. It has 2 plus charge. Oxygen belongs to 6th group. It has 2 minus charge. If the charges are same, they simply cancelled out. If both positive and negative charges are same, there is no need to write any charge. You simply write calcium oxide, because positive and negative charges are equal, or they are already equal, so no need to balance them. You simply write calcium oxide. Similarly, if you are supposed to write the formula of aluminium nitrite. Aluminium has charge 3 plus, nitrogen has charge 3 minus. So you simply, because the positive and negative charge is equal, no need to write the 3 here, because if they are equal, they simply cancelled out and the formula become AlN, just like calcium oxide. Similarly, if you are supposed to write the formula of NaCl, I think all of you know the formula of NaCl. Now we explore our knowledge why this formula is NaCl, why it is not NaCl2. After this class, you get to know about why this formula is wrong and why this is right. You just explore your knowledge and the concepts that I have given to you. You just explore this concept to get to know about that. So basically Na belongs to group number 1, so it has 1 plus charge, and chloride belongs to group number 7, is 1 minus charge. Because charges are same, they are cancelled out and its formula become NaCl. That's why it has formula NaCl, and this is wrong. Similarly, if the negative ions, there are some negative ions, like write the formula of calcium phosphate. There are some, because phosphate is not belong to any periodic table. It is a compound which has a charge, molecular ion, we call them molecular anion. They have charge. So there are certain molecular anion in your course which have charge. You can use them to write any formula, which they are phosphate, sulfate, carbonate, and fourth one is nitrate. Phosphate has formula PO4 3-. You are supposed to memorize them because they are only four in your syllabus, so you are supposed to memorize all of them. Sulfate, it has SO4 2-. It is, this charge is overall. In overall phosphate it has 3- charge, and sulfate has 2- charge. Carbonate has CO3 2- charge, and last one is nitrate. It has charge. Nitrate, it has charge 1-. So if you are supposed to write the formula of calcium carbonate, so basically calcium has charge 2+, and carbonate has charge 2-. If they are same, so they cancelled out, its formula becomes CaCO3. This is the right formula. If you are, let's take another example. If you are supposed to write the formula of calcium nitrate. So calcium has charge 2+, and nitrate has formula NO3 charge 1-. So now they are different charges. You simply crossed it, and parentheses, I said that parentheses we will talk later on. So now we use the concept of parentheses. You simply use brackets. Parentheses mean brackets. You use brackets. In this case, now its formula become 1-. There is no need to write 1 here. Now 2, if you write 2 here, it looks like 32. It's not 32. There are 2 nitrate, so you use bracket NO3 and 2. That 2 means calcium. You know that in criss-cross, the charge of your cation, it become the subscript of your negative ion, so you write 2 here, just like this. This is the formula of calcium nitrate. And if you are this calcium has charge 2+, is equal to 1 nitrate contain 1- charge, so there are 2 nitrate means 2- overall charge. So 2 positive is equal to 2 negative, so this formula is exactly right. Now let's take last example. If you are supposed to write the formula of magnesium phosphate. Now magnesium has charge 2+, and phosphate has charge 3-. Simply cross it, and its formula become these 3 you write here because they are different charges, and phosphate become here. So this is the formula of magnesium phosphate. So this is all about writing formula. So these are the notes here, the valencies of or the charges on the ion must balance if a compound consists of metal and non-metal, the name of symbol of the metal written first. This all notes is for your helping notes. I think I'm finished here to give all the knowledge about how to write a formula, how to write a chemical formula. You simply balance the positive and negative charges. We already done about this. For rules to writing formula, first one is criss-cross rule. You write the correct symbols of elements above each symbol, write the correct valencies, like Al2O3. It become Al2O3 because aluminium has charge 3 plus and oxygen has charge 2 minus. Its formula become Al2O3. Like aluminium nitrate, you use parentheses method, it 3 become here, so its formula become AlNO3 thrice. And similarly sodium bromide, 1 plus 1 minus, they are cancelled out, formula become NaBr. Sodium sulfate, 1 plus 2 minus, different charges, so 2 become here, Na2SO4 is the formula. Like iodide has 1 minus charge, potassium has 2 plus charge, so its formula become Ki. Similarly calcium bromide, these are, and rule 2, when the subscript number is 1, subscript is not written. I've already discussed about that, the 1 plus 1 minus, no need to write. In the case of sodium hydroxide, no need to write 1 here, no need to write here. Like calcium chloride, there are lots of examples. Rule 3, when the valency of both elements are numerically equal but greater than 1, subscripts are not also written. Like 2 plus 2 minus, no need to write because same charges. 2 plus 2 minus, no need to write. 2 plus 2 minus FeO, in the case of this, no need to write. And rule 4, all radicals takes more than once, the subscript is 2 or more, must be in close bracket. This is the rule about parentheses. Like ammonium sulfate, you need to write bracket. Like ammonium, in the case of ammonium sulfate, ammonium has charge, 1 plus, and sulfate has charge 2 minus, so its formula become NH4 bracket 2 and SO4. So this is all about our lecture. If you have any question, feel free to ask me in our coming Zoom session, and please watch this video again and again, and simply nourish your concept to explore the knowledge beyond this. Jazakallah.